This is a mapping process for the composition of functions using the table. So the first thing I'd like to do is rewrite this into f of g of 1. An open circle is the composition of functions, not multiplication. Start on the inside. This is your x value. So on the top, I'm going to find my 1. And then it's g of 1. And g is my bottom row. So that's g of 1, 0. So g of 1 now becomes 0. So now this is your x function, 0. And you need to map that to your f, which is negative 1. Let's do another one. F of g of negative 1. So negative 1 is your x. Here he is. And then g, well, g is the bottom row, which is 0. So now I have f of 0. So 0 is my new x. And now use the f, and he's the first row, and you get negative 1. Let's do one more. G of f of negative 1. This is the x value, and you need f of negative 1. Negative 1, and then f is negative 3. So now we're looking at g of negative 3. Negative 3 is the x, and go to g, it's an 8. All right, now let's do the same process, but using a graph instead of a table. Again, rewrite it into this format. This is your x value. Here's your x-axis, so here's negative 1. Go to the f graph. This is the f graph. This is the g graph. See, they're both labeled. So negative 1, and then go to f. That y value is positive 1. So you're doing g of positive 1. So now here's your new x, positive 1. Go up to g, and he's a 4. Let's do one more of those. G of f of 0. There's your x value, and it just happens to be that I'm already on the f graph and his y value is a 0. So that's going to be g of 0. So there's x, go up to g, he equals 5. So that's a 5. This one's going to be f of g of negative 1. Negative 1 is your x. Go to g, which is this graph, and that's a 3. So you're really looking at f of 3. Here's your 3. Go to f, and that equals a negative 1. F of g of 4. So there's your x, it's 4. Go up to g, and he equals a 2. So f of 2. Here's 2. Go to f, he equals negative 2.